Hey everyone, welcome back. Today we're going to take a look at aqueous solutions. This time we're going to look at concentration with molarity and dilution. So concentration just really refers to the measure of an amount of solute that's dissolved in a given quantity of solvent. It basically tells you how much of a solute there is dissolved in an entire mixture. There are various ways to represent concentration, with the most common way in chemistry being molarity. Molarity refers to the number of moles of solute per liter of solution, and it's represented by the capital M. So let's take a look at an example of where we can calculate molarity for concentration. Suppose a student prepares a 0.7 molar sodium hypochlorite solution using 81.9 grams of solute. We want to know, well, what volume of solution did the student prepare? So we're given here that molarity is equal to moles of solute, and it's moles of solute for every liter of solution. So we are looking here for the volume, hence we are looking for the liters. So if we actually rearrange our equation, we see that the liters of solution is just equal to moles of solute divided by molarity. So what we'll need in order to answer this question is the moles of the solute along with the molarity of the solution. Now we already know that the solution is 0.7 molar. So all that's left is to find the moles of the solute. Our solute here, sodium hypochlorite, we are told is 81.9 grams. So we'll take our mass of solute, 81.9 grams of sodium hypochlorite, and we'll convert this into moles, dividing by the molar mass of sodium hypochlorite, and this will give us 1.10 moles. So then our volume of the solution becomes 1.10 moles divided by 0.7 molar, and our solution will have a volume of 1.57 liters. So molarity can be calculated in order to find the actual concentration, or we could even use it to find the mass of the solute we want to measure out to prepare a certain type of solution. Now suppose we already have a solution prepared. We can actually lower the concentration by doing what's called dilution. A dilution takes a stock solution, so an already prepared solution, and essentially just watering it down. By watering it down, you're lowering the concentration of the solution so that now you can make a series of different solutions of lesser and lesser concentration, but with the target concentration and volume that you have in mind. Now keep in mind that molarity is the moles of solute. Damn it. Let's see. I'll keep this. So we can already take an already prepared solution known as a stock solution and use that to effectively make other lower concentration solutions called diluted solutions. A dilution is essentially just watering it down. You add more solvent, in this case it's going to be water since we're talking about aqueous solutions, and by adding more of that volume you are effectively lowering the molarity and thus you are lowering the concentration. The important thing to know is that when we're making a dilution, the amount of solute doesn't change. Because you're not really adding more solute, instead you're just adding more of the solvent, increasing the overall volume of the solution, but not really changing the amount of solute already present. So if we compare the concentrations of both solutions beforehand, the same number of moles of solute are present in both. However, damn it. Okay. So once we already have a solution prepared, we can take that, known as our stock solution, and essentially just water it down and create what's called a diluted solution. A diluted solution is just a solution that has a lower concentration because you've added more solvent. Keep in mind that when you're just adding more solvent, you are increasing the overall volume of the solution, but the amount of solute isn't changing. Hence, whatever you dissolved in an aqueous solution, that quantity is not changing. It's just how much of the overall volume, aka the amount of water that we've added. So this will lower the concentration of it, creating our diluted solutions. Since the moles of solute don't change, we can essentially compare these two solutions, the stock and the dilution, through this equation, M1V1 equals to M2V2. With this equation, we have an idea of how to prepare a diluted solution if we have a target molarity or volume in mind, essentially figuring out how much an original stock solution we're going to need. So let's see an example of trying to prepare a diluted solution. We want to prepare 250 milliliters of 0.5 molar hydrochloric acid from a concentrated 12 molar solution. So we're asked here, how exactly will we do this? So we're going to need to know, well, how much of that 12 molar solution do I first need to measure out? And then how much water am I trying to add in order to get this 12 molar solution diluted? So this is what our equation is going to be used for. M1 V1 equals M2 V2. So in this case, M1 and V1 refer to the original molarity and volume of the stock solution, where M2 V2 refer to that of the diluted solution. What we're looking for here is V1, because this is the volume of the stock that we're going to need to measure out in order to then dilute this quantity. So if we just substitute in what we know, our original molarity is 12 molar. We're looking to see how much of that 12 molar solution we need. And we know that we're trying to prepare a 0.5 molar solution and 250 milliliters of that. Now in the molarity equation, we specifically need that to be in liters. But when we're just making dilution, it's okay to keep the volume in milliliters, knowing that the volume that we're going to find is also going to be in milliliters. So if we rearrange and solve, we'll see that V1 equals to 10.4 milliliters. So what that tells us is that we're going to need to measure out 10.4 milliliters of the stock solution for this dilution. So the appropriate way to answer this is at the series of steps. Step 1 would read that we measure out 10.4 milliliters of the 12 molar stock solution, because this is the quantity that we need to take out and then just add water to effectively just water down from 12 molar to our target 0.5 molar. So then our second step, once we measure out the stock, is to dilute it or add water until we reach our target 250 milliliters. And the piece of glassware that we want to use here is called a volumetric flask. So we'll measure out 10.4 milliliters of our stock and add water to it up until 250 milliliters have been reached. That adding water is our dilution. And then, of course, the third step is going to be to shake to make sure that we get it thoroughly mixed. So in a dilution, typically we're just measuring out a certain quantity, a very specific quantity of the stock solution, and then watering it down until we get our target volume and our target concentration of what we're trying to make it into.